There is a special type that I think is quite important to talk about, and we'll expand on that after the break. But it's called a pointer. And will talk about what is a pointer conceptually. But the first thing I want to talk about before all that is there are pointers and there are references. Languages like um, Java use references, sort of C sharp, while C++ uses pointers. So let's first ask ourselves, is there a difference between references and pointers? Meaning to say, um, is there a conceptual difference between having a reference to work with or having a pointer to work with? So in order to answer that question, the first thing we need to just go back and review a bit what are references and what are pointers. So let's take a look at a pointer in C++. It would look something like, let's say, int star ptr is equal to the address of some pointer of some integer, right? Or equivalently, you can write it a bit differently, but it has obviously a different meaning. Int ptr would equal to a new integer. The difference would be whether it's on the stack or the heap. But it's at the point though right now where the I is in the stack, or here it's on the stack. Here it's on the stack. Here this integer is on the heap. But that doesn't make a difference for me right now. But notice that this is a pointer, and we're getting the following picture. We are getting this pointer, which is pointing to some value, right? And either I or on the heap makes a difference for me, right? For my discussion right now, it doesn't make a difference. And we're getting some picture that looks like this. And this is the canonical picture of the way pointers seem to work, which means that the address, the value of a pointer is an address of somebody else. So this is the pointer. Let's talk about references. Now, I'm going to write code that looks maybe a bit weird to you guys, but you really know how it looks. Suppose I write the following. Suppose I write int b equals 9. And then I write int reference c is equal to b. Now, this looks weird, I understand. Now, if I say, for example, cout c, I expect to see 9. If I say, for example, minus minus c, and then cout b, I expect to see 8. Okay, so in a sense, we are getting what is known maybe as an alias, meaning, supposedly meaning, that we have a variable called b, and now it's also called c. Notice that the use of b and c are exactly the same. There's no difference between them. So we had b is equal to 9, and then we outputted c, so it just did 9. And then we did c minus minus, and we got 8, and we're outputting b, and it's getting 8. So in a sense, we're getting something which is an alias, which is just like another name for the same value. And now you might think that this line right here is a crazy looking line. Who writes this kind of stuff? So the answer is you do that all the time. When you write a function, right, and you write something like, for example, void foo, which is getting an int ampersand w, and the foo does whatever it does. I don't really care what it does, right? So in a sense, and then you call foo from here, you gotta say foo b, right? Notice you're doing the same thing. You are creating a reference to b. If I had to rewrite the line, I would write it like this: int ampersand w equals b, which is exactly the way we wrote it here. It's the same way, okay? So this type of writing is something you all know and recognize. Just I didn't do it within a function calling. I did it outside of function calling, but it's the same thing. So we say that b here, we say that b is a reference to c. Now, references in Java and C# are doing the exact same thing. So in a sense, we ask ourselves, what is a reference? Is a reference an alias, like I am presenting it over here, or is a reference really this? Just it's doing automatic dereferencing, meaning that when I write the int ampersand c equals b, what I'm doing is I'm creating another variable called C, which is a pointer to B, and not like this, not an alias. And therefore, just anytime I use the name C, I am automatically dereferencing it. Is that what's going on? Or is the first one? Is it an alias or is it not an alias? Okay. Now, the simple way to find this out is to look at the symbols table. Do we have two entries to the same place in memory in the symbols table? In which case it's just an alias, it will be this way. Or do we have two entries to two different locations in memory, in which case it's this way? So which is it? So the easy way to find out which one it is to look at a piece of code. So let's take a look at a piece of code and see what we can see behind the scenes. So here's a little piece of code. Okay, doesn't do much. We have int a equals 7, and we have let reference to r equals a. So this is a reference variable right here. Okay, this is a reference variable. Okay, and then we have a pointer variable. Now I'm going to try to contrast them and see what happens. This is a pointer variable. Okay, and we're going to try to contrast them and see actually how it works. So let's put a little breakpoint right there and start it up and take a look behind the scenes how it looks, what it looks like behind the scenes. So it's running, starting up. And I want to take a look at the disassembly. Now, I can take a look at the memory, but I don't want to. I want to look at the code. I think I look at the code that we see behind the scenes. So over here we see, we'll get to see this kind of code a lot this semester. But let's take a look right here at the lines that we see and we already know. We have int a equals 7. So that's just a move on this line right there. Right? We're having a move the value 7 to the location that is pointed to by the variable a. Okay, that's a equals 7. That makes sense. And then we have, okay, load effective address, and it's loading the value of a into AEX, and then it's going and it's moving that value into R. Notice, okay. So in a sense, it's loading the address of a into R. Okay, let's take a look at a pointer. Let's take a look at the pointer right there. Now, take a look. The pointer, in a sense, is doing the same thing. Notice, it's loading the effective address of A into register AEX, and then it's moving AEX into the location of the pointer. So we are getting, if we understand the pointer version to mean, if we understand the pointer version to mean have a pointer to some value, right? That's what it means. So here too, when we are looking at the previous two lines, you see it's doing the exact same thing. Notice it's loading the effective address, the exact same two lines, except the value is R instead of PTR. But it's the exact two lines. Now let's further down. We're going to do A equals 18. Notice it's moving 18 in hex, which is 12, right? Value, the decimal 18, which is 12 in hex, it's moving that into A. Okay, that makes sense. Now, when we want to move 19 into R, notice it's doing it in two lines, not in one line, which means it's loading the value stored within R into AEX, and then it's moving 19, which is 13 in hex, into the location pointed to by the AEX. So notice that it's actually doing, it's extracting the value out of the pointer, and it's using that as the location where to put the 19. If we look at the next two lines of star PTR equals 20, which is a dereference, so it's doing the exact same two lines. I'm talking about these two lines right here. It's doing the exact same two lines. It's loading the value within PTR, which is an address, into the AEX register, and it's using that as an address where to put 20. So if anybody just takes a look, you can see that a reference variable is not an alias. It's not just the same thing like A. A equals 18 was a one-liner. R equals 19 was a two-liner, even though, which is exactly the same two lines like the pointer line. So in a sense, when we use a reference, what we're actually doing is we are just getting an automatic dereference. Take a look at the line R equals 19, the line right there. And the line star PTI equals 20. Notice here we're getting automatic dereference, and over here we're getting a non-automatic, a manual dereference. But besides that, they're doing the exact same thing. So references, which is the first step of what I want to talk about, references are not aliases. References are pointers, just like regular pointers, which means that if we look at that at the symbols table, we'll get to see two different addresses. The address of PTR and the address of A, of this value that we have here, I, are not the same. They're actually very two different. And the real picture is this picture right here, even for references. The only difference is that we're getting the automatic dereference, which we are not getting when we use pointers in C++. Now this is true for Java, this is true for C#, it's true for all of them. When you use references, you are just using pointers, you're not using pointers as a pointer, you're using it as a dereference to the pointer, and I will talk about that more further down the line. Therefore, by the way, when we are inside a function right here, inside here, and we access W, why does that change the original B? The reason for that is because we are actually getting a W, which is pointing to B. This is W, this is B. W here is in scope, right? This is in scope. And this is outside scope. But it's just a pointer. And therefore you can actually access anything you want on the outside. Except anytime you use the word W, it's giving you star W automatically. And therefore references and pointers in a sense are exactly the same thing. There's no differences between them. They are the same thing, they are one and the same. And the only difference, as I said, is whether you're getting automatic dereferencing or you have to do it manually.